Hey class, this is Mr. Roberts at Shasta High School, and I'm here to help with our homework assignment tonight. Again, my recommendation is don't do every problem this way, but if you're stuck on something and you've got questions and you're like wondering what, please feel free to use these. So let's start with question number 30. It says, write a simplified algebraic expression for each expression mat below. So here is an algebra expression mat. It has both the positive and negative region. Remember the negative regions, we write algebraically by using parentheses with a negative out in front. And a reminder that when we look at these as black and white ones, if it's shaded, it has a value and it's positive. And if it's not shaded, if it's open, it's a -1. So remember, shadeds are positive. The ones that are open, -1. So if I look at this very first mat, I guess the first thing I would do is I might, oh no, it says just go ahead and write it out what this is. So it doesn't say we have to simplify it with the mat. So let's do that, which I think is easier than manipulating the tiles. So let's see here. In the top, we've got 2x's plus there is a 2, and then there's a -1. Now below, in the negative portion, right, you can see I write minus, open parentheses. Those are positive 2's down there. So this is what this mat is. And if I was to simplify this, I guess I might write 2x plus 1. And then this, right, because there's this negative here, and this is the negative, I'm going to bring it out, and these are going to have to become -2's. They were positive 2's below, but now they're -2's. And then as a final step, I would write that this is going to be 2x minus 1. Let's go over to mat B. This one has, if I'm just going to write it down, it's a positive x, that's this one, minus an x, that's this one, plus 3, and then below I have a minus, and this is a -1, right down below, because it's shaded, that, or not shaded, that's a -1. So let's see, an x and a -x is 0, so I'm looking at 3, and then to bring this negative out of the parentheses, same thing to bring it up here, I have to change its sign, so this would become a +1, so I'm looking at 3 plus 1, or this is 4. So mat B is the number 4. And then our final mat is C. Ooh, and we've got an x squared and a y. Okay, so let's see. Out of the parentheses, there is an x squared that's positive, and then, oops, and then we've got negative, so I'll write minus a 2. And then in the parentheses, right down below, there's the negative, there's a positive y, and a positive 2. So if I bring these out of the parentheses, right, the negatives, I still have the x squared minus 2, and then it's going to be a -y and a -2. One last thing I could do is I can combine some like terms. You can see there's a -2 and a -2. So this would look like x squared minus y minus the number 4. And that's expression mat C. Next question, I believe, is 31. It says, simplify the following expressions by combining like terms if possible. Okay, if possible. Algebra tiles may be helpful. So I guess the reason why we're saying if possible is because sometimes you don't have any like terms. However, for A, I do have some like terms. So I'm going to use some colors to kind of indicate them. I have an x, another x. I have a 2x and then a -x. So quite a few terms that involve x. There is one term that has an x squared. And then I have a single term that's just a unit, right? So if I combine these together, I've got 1, 2, 3, 4 x's minus an x is going to give me a 3x. So this blue stuff is all 3x. Then the green is the 4x squared, and I probably would write that first. So I'm going to write 4x squared, and I can see it's positive. And I've got plus 3x. How did I get that? I've got an x plus an x plus 2x's, that's 4x, and then minus an x gives me the 3x. And then finally, minus the number 3. So there's A. I think this is right. B. Ooh, okay, let's see here. So in terms of, I see x squares, right? So there's 8x squares, or there's a negative 13x squares. They're negative. Here's a 10. And then in terms of x's, I can see that there's 3x, a negative 25x, and then another negative x. So definitely my answers are going to have x squares and x's. And am I using a calculator? Yeah, I'm going to, really? Yeah, go ahead. So if I use a calculator, because I don't do arithmetic, I always make mistakes. No, that's not true. Let's go ahead and look at our x squared term. So I've got 8x squares, and then I've got plus a negative 13. So I've got 13 that are negative, and then I've got plus 10 more. So it looks like I've got 5x squared. Now, I could do that a different way. I could just say, hey, 8 minus 13, right? And then I could say plus 10. I know that 8 and 10 is 18. 18 minus 13 is 5. So I got pretty good confirmation that mentally anyways, that this is going to be 5x squared. And then in terms of my units, you can see there's a positive 3, I mean my x's, there's a positive 3x. There's a negative x, which is going to make that 2x positive. And then there's a negative 25, which should leave me at negative 23x. I think that's right. So if I take the number 3 and I add to that a negative 25, then can I add to that a negative 1 to get that? Yeah. And that's the same as what? It's the same as, why am I doing this so many different ways? 3 minus 25 minus 1. Clearly overdoing it. That's exactly what it is. 25x squared. I'm sorry, 5x squared plus a negative 23 or minus 23. Let's go to C. Oh, in C you can see I've got X tiles and Y tiles, but there's no tiles that are alike, right? There's no terms that are alike, so I can't combine those. So I'm going to have to leave this right there. I cannot combine those terms. I could multiply them if it was 4x times 3y, but that's not what I have. I have 4x plus 3y, so I'm going to have to leave that one alone. And on this last one here, ooh. Okay, I've got some, I've got 4y squared, a negative 2y squared. I can see there's a 10, a negative 3, and a 20. And the other character that's showing up here is there's a 3xy. Completely different than x's or y's. It's a 3xy. Get off my screen, calculator. There you go. So if I combine the, I guess let's go ahead and write the y squared first. So 4y squared minus 2y squared is going to give me 2y squared, right? Positive 4 minus 2, 2y squared. And then the xy's, there's going to be plus 3 of those, 3xy. That's the part in green. And then the last part I have is 20 plus 10 is 30, and 30 minus 3 should be 27. So I've got plus 27. So that is part D. Let's move on to question 32. Yes, 32. Uh-oh. Kind of crowded here. Let's see. It says, oh, read the math notes in this lesson about evaluating expressions. Evaluate the expression below for the given values of x and y. Okay, let's do that. Let's take a look at the math notes real quickly. So to evaluate an expression or function with one or more variables, you should calculate its value with a number in place of the variables. Placing parentheses around the substituted number will help you avoid mistakes. That is worth underlining. Placing parentheses around the substituted number will help you avoid mistakes. For example, when you evaluate x squared plus 4x minus 3 for the value of x equals 5, the result is, now I'll write this, you can see it, that's there, but putting parentheses, we're going to put a 5 in where the x is, and we're going to square that, plus 4 times parentheses, a 5 where the x was, and then minus 3. I'm going to square the 5, that gives me the 25. 5 times 4 is plus 20, and then I'm going to subtract 3, so we get an answer of 42. You can see the same work there. Note how the 5 was placed in parentheses when it replaced x. That's solid advice. That is a good bit of advice. Next, I think there's a typo here. It says, when an expression is part of a function, you may evaluate the function when x is a specified value. For the function, now this is the typo, the function should be f of x equal to the opposite of x squared plus 7. And I want to evaluate that when x is the number 6. So I'm looking at f of 6. Let's put a 6 in for the x. And that's going to equal the opposite of, open parentheses, x gets 6. Right? I put a 6 right there where the x was. Square that, plus 7. All right. Now, this is the opposite of 6 squared. 6 times 6 is 36. And then I take the opposite of it. That's going to be a negative 36 plus 7, which gives me negative 29. So when x is 6, when I put 6 into this function, I get out negative 29. Always remember to follow the order of operations. The order of operations explained in the math notes box in the previous lesson. Good to know. We can go back and look at that. And then let's see here. Evaluate expressions with exponents can be challenging. For example, if x is negative 3, then x squared is, oh yeah, you see this. X squared is negative 3 times a negative 3. Parentheses were placed around the negative 3 when it replaced x. The exponent affected the entire expression inside the parentheses. So a lot of times when I would write this, I would say, hey, I'm trying to evaluate what x squared is. And I would say, oh, x is negative 3. So if I put negative 3 just like that in parentheses, what that means is a negative 3 times a negative 3, which is positive 9. Now, here's another typo. It says, if x equals 3, then this is supposed to be the opposite of x squared. The opposite of x squared is a negative 3 gets squared equals. So this is silly, right? So let me just do this. So I'm trying to evaluate the opposite of x squared. So I'm going to go ahead and take my parenthesis value. It is a 3 that goes in for x, right? 3 goes in for x. And then, right, I'm going to square the 3, which is 3 times 3. But notice I've got this negative dangling out in front. So this is negative 3 times another 3, which is going to be negative 9. In that very same expression, boy, let me just write this down because whoever proofread this did not do a good job. If x equals negative 3, then the opposite of x squared. Okay, so let's look at this. So if I want to plug negative 3 into that, that's going to look like, here's the negative that I already saw, open parentheses, close parentheses, square it. What I'm going to do is I'm going to place negative 3 inside of there. So what I'm looking at right now is the opposite of a negative 3 times another negative 3. Negative 3 times negative 3 is positive 9. So what I'm looking at is the opposite of 9. So that's negative 9 also. Okay, so we're going to do a few of these now that we've reviewed the math notes. Let's go back and look at our book right here. It says evaluate this expression if x is 3. So if x is the number 3, we're going to be looking at 6 over, I'm going to use parentheses as it was recommended, 6 over 3 plus 9. 6 over 3 is 2, so this is going to become 2 plus 9, 9, 10, 11. This is the number 11. Nice. Let's look at B. Ooh, evaluate the opposite of x squared plus y if x is 2 and y is 1. Okay, so I think I got this. Here's that negative symbol and then a space for x. I'm going to square that and then plus a place for me to put y. So in place of x, I'm going to write the number 2. Right, that's what x is. X is 2. And in place of where the y variable is, I'm going to write 1. This becomes the opposite of whatever 2 times 2 is, plus 1. That means this is going to be negative 4 plus 1, or we get negative 3 in this case. Negative 3. That's B. All right, and now C. Oh, they're going through the paces here. This one says evaluate the opposite of 2 times x times y. So you can see I've just used wherever the x and y were, I've just opened up and closed parentheses for each variable. In place of x, I'm going to put the number 5. And in place of y, where y was, I'm going to place the number negative 3. So if I multiply from left to right, negative 2 times 5 is going to give me this negative 10. And negative 10 times negative 3 is going to give me a positive 30. So this one is 30. And then the last problem is here. What a mess. This is 2 times x is going to get squared and then minus a place for y. I think I got it. So in place of x, I'm going to put the number negative 3, right? X was negative 3. I put a negative 3 here. And then in place of y, I've got this minus, and then I have a spot for the y. In place of y, I'm going to be placing the number positive 8. So when I square negative 3, right, I'll write it below here. That's going to be 2 times negative 3 times negative 3, which is 2 times 9, which is the number 18. And 18 minus 8 is going to give me the number 10. So I think we've got all of those. Let me zoom out here and just do a quick double check, make sure we're correct. All right, a little crowded, but I think those all check out. All right, so let's go to the next one. It says use legal moves to determine which side of each expression mat is greater. So of these two, which one's larger? So I have seen problems with the CP/M e-tiles not being set up properly, but I'm just double checking here. On the left-hand side, positive, I've got negative 3 and a plus 1. Down below, there's a negative x and a plus 4. On the right-hand side of the mat, oops, this is not what the book has, right? The book has a positive 1 and a negative 1. But let's see, and then an x, but I need another positive 1. So let me drag another positive 1 into that section. Yeah, and then down below, there's a positive 3. Okay, I think this would have turned out to be equivalent though. So at least their errors cancel each other out. So I think this is the mat that I see in the book. So let's go ahead and do this. So legal moves, wow, I could move this up to the positive side and has to switch signs, and I did. Now that I've done that, they both have a positive x. There's one on the left and one on the right. So I can take those away. They're gone. These 4 positives are going to move up. They all have to switch signs, so they're all becoming negative. These 3 all move up. They have to switch sides. They all become negative. And as I group these together, right, there's a 0, there's a 0, there's a 0. So there's nothing but zeros over here. I can get rid of all the zeros on that side. And over here, there is a single 0. I can get rid of that. So what I'm left with is on the left-hand side, I see negative 6. And the right-hand side, I have 0. So I can write, I hope this is right. Right, negative 6 is less than 0. So the right-hand side is larger. The right-hand side is larger. Let's take a look at part B. See, I hope this is B. All right, looks like a miracle. I'm pretty sure this matches what was in the book. So couple things I can do right away is I'm going to move this one out of the negative into the positive, switch signs. As soon as I do that, that's a 0. This is a 0. I don't even care about the other side. These can go away because they were zeros. Right here, you can see I clearly had a 0. That can go away. Yep. There's 2 negatives here. I'm going to move these 2 up, and they both have to also become negatives. So now I'm looking at -4 over on the left-hand side, and I'm looking at 0 on the right-hand side. So I believe for this one, we would say -4, not -6, that's the previous problem. We'd say -4, -4 is less than 0. So again, the right-hand side has it. It is the larger of the two. Alicia used 4 gallons of gasoline and traveled 90 miles. Is this proportional? I would say yes. My thing I'm always considering, would it make sense if I used 0 gallons of gasoline, I would travel 0 miles, right? Is 0, 0 part of this? Yeah, absolutely, right? No gallons would get me no miles. So this is a proportional situation. Yes, it goes through the origin. Now that I've got that, right, at this same rate, how far can she travel on a full tank that holds 18 gallons? Okay, so let's see here. 4 gallons will get me 90 miles, but now I've got a full tank, 18 gallons. How many miles would that get me? This is a proportional. This is a proportion, right? It's one fraction equals another fraction. One ratio equals a ratio. So to solve this, I could multiply both sides by 90x. If I did that, that would be equivalent to observing that these cross products are equal. So this is the case. 4x is going to be exactly the same as 90 times 18. 4x is 90 times 18. And yeah, it's true. Multiply both sides by 90x and you would see that the equation becomes that. But for now, it's clearly a proportion. So let's just leave it here. Let's grab my calculator. And on my calculator, I'm going to just go ahead and go 90 times 18. That's the wrong. I'm clicking on the wrong screen. Let's see. Clear. It's going to go 90 times 18. 90 times 18 gives me 1,620 on this side. Over on the other side, we've got the 4x is equal to that. And I'm just going to divide both sides by 4. So x is going to equal 620 divided by 4. I think that can be simplified. So x equals 1,620 divided by 4. X is 405. So I could go 405 miles on a full tank of gas that holds 18 gallons. All right, that's question, what was that? That was 34. I think we've got one more to do. Let's go down to 35. Here it is, 35. And let me get rid of the calculator. It says, the 2 lines at right represent the growing profits of companies A and company B. Sketch this graph on paper. If company A started out with more profits than company B, determine which line represents A and which line represents B. Okay, so it says if it started out, if company A started out with more profits. So starting out is here. So that would mean that this line would have to be company A, right? That would have to be the company A. And this red line would have to be the company B, because company A started out with more profits than company B. So that's my answer for part A. And then next it says, are the profits of company a proportional situation? Why or why not? Oh, definitely not, right? Definitely not, because 0, 0 is not part of the graph for that company, right? So that orange line, that it's not part of it, so it's not proportional. Nope. Doesn't go through the origin. Next, it says, in how many years will both companies have the same profit? Oh, well, the same profit's going to happen. I think maybe the color makes it bad. The same profit's going to happen right here. Let me put like a little blue dot right here where they overlap each other. And if I'm wondering where that's at, I'm just going to drop a line down, straight down. And it looks like it's very close to 3, right? So I would say maybe a little bit more, but I would say same profit is about 3 years. And then approximately what will that profit be? Oh, okay. So when they have the same profit, the question is, what will be that profit? So what I'm doing is I'm saying, okay, in 3 years, right, over, I just take this back, I go straight up to the point, go over, and it says somewhere in here. Now, if this is 100, right, I need to think about the scale, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So each one of these is 10, and they're in thousands of dollars. Profits in thousands of dollars. These are small companies, right? So I'd say 10, 20, 30, 40, 50, 60, about $65,000, I'm guessing, right? So somewhere in between 60 and 70. So I would say approximately what will the profit be? $65,000. Now remember, I'm reading that question in context of C. C says, hey, how many years will both companies have the same profit? Well, in 3 years. At that time, when they have the same profit, right, what will the profit be? $65,000. And it says, which company's profits are growing more quickly? How can you tell? Ooh, which one's growing more quickly? I would say that the company that's growing more quickly is B. And I would say that because B starts out lower, but it gets higher than A, right? Over time, it gets higher than A. And also there's this idea of, the slope of a line, the steeper it is, the more quickly a company's growing. So I would say that B is growing more quickly. So right here, I'm just going to say B is growing more quickly. All right, that looks like it. 27 minutes, under 30. Thank you. I look forward to seeing you again soon.